YouTube. This is a two-part video. I'm going to show you how an SQL injection and cross-site scripting attack actually works, and then we're going to block those attacks using the AWS WAF version 2. Let's get started. So I created this test site with just a basic page. And by looking at the page, there's not a whole lot going on here. If you view the source, really doesn't have much. You have an IP address. We'll see what that's for when we go to block the attack later. So now if we go to Burp Suite, let's take a look here. We'll close the source. There we go. Proxy intercepted that, and here's our HTTP history. So there's no parameters detected. So how do you hack a page or do SQL injection on a page which doesn't have any parameters? Well, we'll see in a moment. There's a special tool called Arjun, which is a hidden parameter discovery tool. So let's go ahead and check out these pages using Arjun. We'll start with hidden page 2. And this isn't on Kali Linux by default. You have to clone the GitHub repo. And then just make the Python script executable, and that'll let you run it. Let's go ahead and paste that in. So we'll see if Arjun is able to find any parameters. So basically what Arjun is doing is trying common parameters. It has about 25,000 that it looks through. And if the page uses any of those parameters, it'll show up on the output. So it found one called field default value. Let's also check the other page and see if it finds anything there. So this time it found two parameters, field default value, and then one really long one. So on hidden page 2 we have field default value. So we'll go back here and then we will use that So we'll go ahead and mark it as test. This is pausing because the intercept is on. I'll turn that off. Don't need that for this particular demo. So here we go, and we see it reflects the value back, so anything we change is reflected back there. Let's see if it's vulnerable to cross-site scripting using JavaScript. And we see the pop-up here, so this is vulnerable to cross-site scripting. Now, what we want to test for is if it's vulnerable to SQL injection. So we'll do something like test, single quote, or 100 equals 100. And it just reflects it back. We'll try adding a couple dashes on the end. Nothing going on there. So from this, it doesn't look like the parameter is SQL injectable. Let's try one more thing. We'll do value equals test, single quote, space, and sleep to dash dash single quote. And It's just reflecting it back. It's not sleeping. Let's try it with an OR here. And notice the page is trying to load. It says waiting for this page. So the sleep here is working. What this is a sleep for the MySQL database server. It just finished. So this parameter is SQL injectable. And what you could do, or what a hacker may do, is send thousands of these requests to your page with a parameter like sleep 3000, and this would crash your database server using up all the connections. No real users would be able to connect then. So let's go ahead and send this to burp repeater. So we have the request here. We could see it's being reflected. Let's go ahead and save this to a file. And we'll call this burp.txt. Now let's use SQL map to see if SQL map could actually get any data from this SQL injection. So this is the command I'm using. And I'll take out these options for now. So let's go ahead and run this. And it says might be vulnerable to cross-site scripting, and now it's going to try it for SQL injection. Well, that's running. Let's go ahead and test the second page. I think it's trying to run it with 3000, so I'm going to close this. So now this one's hidden page. So again, looking at the source code, there's not a whole lot there. And we know this one has two parameters from our output from Arjun. So let's try this one with the really long parameter. So we have test reflected back. So we have cross-site scripting on here. We have the alert as well. Now let's check out this page in burp. So that's hidden page with the longer variable. Send to repeater. And this will work with get or post. So we could even try changing the request method. So that'll change it to post. Put the parameter down here at the bottom. We'll go ahead and send that. And you see the value is reflected back. So let's go ahead and save this to a file. We'll call this one burp2. And we see the first one's still running. It's trying exploits for different database servers. This is a MySQL server, but it doesn't know at this point, so it's trying PostgreSQL, Oracle, whatever it could find. So let's go ahead and run our command again. All right. So we're running this with level 5, risk 3, random agent, technique B, current user, and 5 threads. If this doesn't work, you could try a few different things, different techniques. You could try adjusting the level and risk, and you could also try a different SQL version. I've noticed some of the SQL map versions return something different. You may get an SQLi map that does not work with the latest. You may get an SQL injection that doesn't work with the latest SQL map version, but it'll work with the older one. And in this case, I'm using version 1.4.7, which is, I believe, a couple versions back. So the SQL map finished and was able to find the username of the database server. So let's go ahead and check for the actual databases to see if it could get more data. And there it found information schema, MySQL. So those are system databases. Not concerned about those. So let's run it with a flag to exclude those. And see what it finds. And it is still checking those. So that may not be the right flag. Let's see. It says exclude sysdbs. Let's go ahead and try to change the order. And it is still checking them. So I did find 5 databases. These all look like system default databases, except for this one here called secrets. So let's go tables, see if we could find anything else that's good. And again, it's doing these system databases. All right, but it didn't find the tables for those, so maybe it still finds the database name, even if you exclude it, but doesn't do the tables for those. So we did find the tables. Let's try columns. And it looks like it's finding the columns here. We see int6 unsigned. We see username. We see password. And we see secret question. So this looks like it's a login database. And it found all these columns. So we have secrets, logins, and then all the columns. Let's try to get some of the actual data and see if we're able to find any data. And it's looking promising. I see password and leet. We have a username admin, let me in leet. While this is running, let's check our SQL map from the first one. So this was the SQL map on hidden page 2. So hidden page 2 is not injectable. But we saw it was injectable using sleep. You just can't get any of the data from the database tables. So with the page, hidden page 2, you could only crash the server with an SQL injection attack. You can't actually extract any data. However, with the first hidden page, you're able to get a full database dump. So you have your database secrets, table logins, and then it has the username, password, secret question for all the users here. And this saves them to a file. So you could just go back and look at that file, which is in CSV format, to get all the users, all the passwords. So that's how a basic cross-site scripting and SQL injection work. Join me in part 2 to see how to block that using AWS WAFv.